I want to share with you a way of analyzing a URL dataset on a large scale. In this case, we have 2.4 million URLs, and these are from a web server log file. So let me show you the problem first and what the challenges are. These are some imports of the packages that we're going to be using, and we start with a URL list CSV file, which is 205 megabytes, as you can see here. Okay, so we read this into a data frame with pandas read CSV, takes 2 seconds, and with the dot shape attribute, we see that we have 2.4 million URLs. These are the first five. This is how they look. And in order to analyze, we want to spread these, we want to expand these URLs into something like this. Okay. So we have the URL to df function, which we run it on this list of URLs. It takes about 2.5 minutes, and it gives us this. But this data frame, if you run info, you can see we have 316 columns, and it takes 5.7 gigabytes of our memory. That's huge. Now let's see how much time it takes to run normal operations. So if I just simply want to sort the values of this data frame, let's say by directory 1, it takes 16 seconds. This is like, we're not running machine learning or any models, or this just sort by a column. I want to see how many of these columns are full, and not empty or not NA. So I run this simple query not na.mean.sort values, and I do some decoration here. Just to produce this takes 17.8 seconds. So what does this mean? So this means that the URL column is 100% full. We don't have any missing values. Directory 3 is 84% full, and so on. And then something interesting here is we drop suddenly to 1.6. So this column with the query parameter ignore nitro has only 1.6 of its values full, and like 98.4 of this column is empty. This column is 99.6% empty. So, we have about 300 columns by 2.4 million, just to say empty, 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 empty. And it's not only this 5.7 gigabytes, it's when you process this, you use more and more memories because you have intermediate values and so on. So this is a screenshot of after a while of working on this. Remember, just sorting and doing very basic operations. Just this one Python process is consuming 18.3 gigabytes of my RAM. Now, if your RAM is 16, then this is going to crash long ago. So this is our main problem. Now the solution to this is that the URL to df function has a new parameter. It's called output file. It runs the same way, it does the exact same thing, but instead of loading a data frame into your memory, into your RAM, it saves it to a parquet file to compress it. Okay, so the good news is now we have this URL df.parquet taking only 67 megabytes of space, and this is not in memory, this is on the disk. So this contains the same information as the 5.7 gigabytes. Okay, and now there's a different approach of doing this. We don't read the whole data frame and operate on it. We use the read parquet file, function, and now we can only take the columns of interest. So in this case, I want directory 1, and I run the info method, and I can see that this is just 18 megabytes of data because this is just one column, and this operation took 147 milliseconds. So this is, solves the problem of large data. So let me show you a more extensive example. Now that we have this URLDF parquet file, what we can do. So these are the same imports. We have a new function called parquet columns under the Crawlytics module of advertools. It's very simple. It just shows you what columns you have and the data types: string, integer, date, time, whatever. So we still have 316 rows representing those columns. So we read parquet this file, and we select the column scheme and run the value counts, and we get everything HTTPS. We run the same thing with schema network location, and we get, again, like no other subdomains and so on. Now let's go to directory 1 and see what we have. And we have WP content, includes category, and so on. So 92% of our traffic is just in these 5 directories. Remember, this is traffic to a log file, a web server log file. Okay. So after directory 1, I'd like to see directory 2. But I don't want all the values. I want the values where directory 1 is equal to WP content. Okay, so under this, I want the same table, but under this one. So we have the same function read parquet, but we also have something called filters. Okay, so read this file. I want only these columns, directory 2, but only where directory 1 is equal to WP content, and now count the values for me. So under WP content, it seems we have uploads, themes, and plugins, and the rest are just tiny values. So you can see how convenient this is and how easy. Let's run the same thing for directory 3 with 2 conditions. Directory 1 is equal to WP content, and directory 2 is equal to uploads. And we can see that directory 3 is these 4 years, and the rest are negligible. So it seems like the biggest chunk of our traffic is coming to WP content /uploads/year. So let's see if we can get the articles per month in 2022. Same thing, we read parquet and we take path and directory 4. The path is the full, everything after the slash of the domain. And now we have 3 filters. Directory 1 is WP content, directory 2 uploads, and directory 3 is 2022. And now we drop the duplicates in the path column. So because this is traffic, so the same URL gets multiple hits. And now we count directory 4 with path deduplicated. So we know how many articles or how many products. This is an e-commerce site, and it seems January, February, and March. These are the numbers of products that we have. We can run the same thing with 2021, and we have much more data here for the whole year. Again, you can see it's in May, June, and November. They've added many more products. Now, running the same thing without dropping duplicates tells me about the traffic. Okay. So we had 175,000 hits on WP content /2021/05, where and this is for 1,307 URLs. Okay, makes sense. Like the folders that have a lot of products in them would probably get much more traffic than the others. We can do the same thing with getting the number of hits on last directory, which is the slug, the last part. Same thing. We run the filters. We take last directory, and we can count them. We can see which files have been the most hit, and we can get the sizes of those and maybe optimize these and do whatever we want. And just to show you how fast this is, I want to run this again for you. See, it just doesn't take. Let me actually rerun the whole, restart and run this whole notebook. 1, 2, 3, 4, 5, 6, 7, 8, 9, not even 10 seconds to rerun all this analysis. And all this because we have the parquet file compressed and contains all the values without having to clutter the memory with 5 or 6 gigabytes of our RAM. So that's it. I hope you liked it. Let me know if you have questions or issues. Thank you very much.